Greetings. In this video I want to introduce the general steps that would be necessary with any type of statistical analysis. And in this section 3 of the class, this is really kind of what we're getting at. So let me just kind of get a basic title up here. Let's call this a general step-by-step guide. Okay. So let's just kind of hit the first point here. The first step is really going to be restating your research question. I'll just abbreviate that RQ for research question into a null and alternative hypothesis. Now this can be a written null, an alternative. It can be a statistical null, an alternative. And if you recall what those are, or maybe you don't recall what those are, I would encourage you to go back to the video from a prior module that was covering research questions and hypotheses, and I go into detail about the differences between written and statistical nulls. My preference here is to try to state these in statistical nulls because I think it is more intuitive when we start looking then at the equation for the statistical test. I think the equation has a nice correspondence to the statistical null form. Okay, so the second step here, and these are again these are general. You could look in a dozen textbooks and get a dozen different ways of kind of chopping and slicing this process up. This is just the way I kind of chunk the process together. So after we restate the research question into a null and an alternative, we want to determine the characteristics of our comparison distribution. Alright, so let's try to make sense out of this second step. Actually, let's just go on with the steps and then I'll come back to each one of these. Okay. Step 3 is then we want to determine the cutoff on our, I'm just going to call it CD, our comparison distribution. Our fourth step is going to be to determine then, actually I'm not going to say determine, let me back that up. Let me say calculate our t-value from our sample kind of 5 then is going to be make a decision. That is kind of does our calculated t-value greater or that less than this cutoff t-value. This will make sense in a minute here. So let me just say cutoff t value up here. And then really the last step is then to provide some meaningfulness to this decision, and this is to calculate and interpret an effect size. So that we won't get to this effect size piece until probably this will probably be module 15, probably our last module that we'll do together, I'm guessing. But these other 5 steps we'll be doing really over the next, I guess, 2 modules together. So let me try to quickly go in here and clear some of this up. So I think the first one is pretty self-explanatory. I'm going to switch to a different color here. We'll go to blue, where we're restating the research question into the null and to the alternative hypothesis. Again, go back and see the other video. Now, determining the characteristics of our comparison distribution. So let's just recall for a minute here that, kind of bring this up to here, that when we're doing a t-test, it might look something like the form from a research design perspective, where you're putting maybe n equals 10 individuals into and randomly assigning them to get the treatment, which is x, and then making an observation. Then you're taking another n equals 10 individuals and randomly assigning them into a control group where they get nothing, no treatment, and then you're going to make an observation. Here's observation 1, observation 2, and then at the end of the day, this O here really represents a mean of 10 individuals that got the treatment, and this O really represents a mean of 10 individuals that were in the control group. And you want to compare, it should be O2, sorry, O2, and you really want to compare O1 to an O2 comparison to say, did my treatment have an effect relative to the group of people that did not get the treatment? That's really what you're trying to do here. And at the end of the day, you're going to try to make a statistical determination. Can the mean of this group here be considered different from the mean of this group down here? So to do that, we have to have a comparison distribution. Well, what is the null hypothesis here? The statistical null here, if we wrote this in statistical form, might be that the mean of group 1 minus the mean of group 2 equals 0. That is, they are the same, i.e. my treatment did not have an effect. Whatever the mean of this group 1 was, it was the same in group 2. Therefore, whatever my outcome variable of interest was, the treatment here, whatever it was, a drug or whatever, it did not cause the other group to be different. And that's how we got the 0 over here. Okay, well that makes sense so far. So what is this comparison distribution? We'll recall, and I'm going to make a copy and paste here for us. Recall that a normal distribution, which is this one right, I'm going to get back to my pen here, which is this one right here, the standard normal distribution. This took a particular form for us, and I won't necessarily bore you with this, but if you remember, and you can go back several videos here, but this was the equation for this. Point being here is that this line right here, the standard normal line, it doesn't change, and we're familiar with the center point of this being 0. Again, we have z-score of 0. Between +1 and -1, we would get about 68%, and between about -1.96 and +1.96, we'd get about 95%, right? Going from here to here. Okay, so we're familiar with this, but in doing a t-test, statistical test, we're not using the normal distribution. And again, just as a kind of a reminder here, if you had a z-score that was to, say, this side of 1.96, maybe it's -1, -1.5, you would say, well, that's not a very extreme score. But if it was on this side of 1.96, you might say that's a pretty extreme score. So extreme, in fact, that I wouldn't consider it part of the population any longer. And that's kind of the same thing we're doing here, except notice that this t-distribution, I'll switch to red for the t-distribution. Here's our t-distribution. It starts out shorter, and then it has thicker tails. So if you look at the tails here, this vertical distance here between the x-axis and the function, the line of the function here, is a greater distance. So thicker tails and shorter, kind of stubbier in the middle. And so what happens then is this t-distribution will change with degrees of freedom. The symbol for degrees of freedom is this lowercase nu. This is degrees of freedom, right? And it's equal to n-1. So if you have at every n, you're going to have a different shaped t-distribution, and these t-distributions will kind of get, as you increase in, they'll kind of come up like this, and those tails will get a little bit thinner. If you keep increasing in, it kind of comes down like this. You keep increasing in, you start to do what? You start to approach kind of a normal curve as n goes up. Okay, and so the point here being is that you have to determine what are the actual what's the shape of this curve going to be. When we say determine the characteristics of our comparison distribution, this t-distribution represents this null hypothesis, right? You know, that if you were to go out and do this in a population, this is what the shape of that distribution of scores would be in a population where your treatment is not having an effect. And the shape of that distribution changes as a function of how many people are in your sample right here. Okay? And so that is the second step here. So this is just simply what? Knowing your new value. So determining your shape of your characteristics is simply just knowing this piece right here. What is my new value? Okay? So then step 3, determining the cutoff. Well, the cutoff in a normal curve is 1.96, but because the shape of our curve is changing for every n-1, that means that if we want to capture scores that are going to be outside of the 95th percentile on either side, plus or minus, then the critical score is going to change as a function of n-1. And so let me kind of show you here with another cut and paste what that would kind of look like. Before I do the cut and paste, let me show you, let me do this for you. So we want to determine our cutoff, so we're going to calculate what's called our critical t, and our critical t is t at a particular alpha that we choose, 1 or 2-tailed. Generally we're speaking, we're looking at 2-tailed. We're looking for scores either over on this side of the line, of our cutoff line, or over on this side of our cutoff line. And then at a particular new value. So what is this alpha? If you remember, go back to the lecture on alpha. Generally speaking, by convention, we kind of constrain this to alpha 0.05. This could be 1-tailed or 2-tailed. Generally speaking, again, you're looking at 2-tailed, and this new value equals n-1. So if you go up here to what we said, we had a total n of 20. So a new for us would equal 20 minus 1 equals 19. Say we wanted to do it two-tailed and it was alpha. So what we're going to look for in a critical t table is we're going to look for a t value at 0.05, two-tailed, with degrees of freedom 19. Now how do we get that? Here's how we get that. We'll just put this on just for a moment here. You get this by simply going into a critical t table, and if you'll see here, you're getting, get back to my pen here. You're getting your one-tailed and two-tailed here, and then your degrees of freedom is right here. So this is your new column. And so let's look at ours. So we said we want this t value right here. Where do we find this t value on the table? So we want to be two-tailed. So we're going to read somewhere off of this row right here, because that's the two-tailed row. And we want 0.05. Well, where's the 0.05? 0.05 is right here. And then we want degrees of freedom 19. So we come down our degrees of freedom till we get to 19. And so what we want essentially is the intersection here and the intersection here, which gives us this value right here. So critical t for us is going to equal 2.093. Now what is this 2.093? It's simply the cutoff. See, we had a cutoff here for a normal curve that captured 95% to this side of the line at 1.96. Now what we're saying is the shape of our curve is such that to capture 95%, you would have to come out to 2.093 and 2.093, and between here and here now you would capture 95%, such that anything that's past this side of the line you would consider now abnormal. Any t-score that you got to this side of the line you would consider to be the same value. Okay, so to this side, if we're going back to our typology, you would fail to reject on this side, and anything on this side, you would reject the null hypothesis. Okay, so that is that particular. See if I can get this back off of here again. Okay, so that is that particular piece. So then the last piece we have to do is determine our sample's t-score on the comparison distribution. That's going to be in the next video, where we go over the t equations. Then we'll simply make our decision: does our calculated t from the equation beat this critical t? So again, this is critical t. So when we calculate our t, is it less than or greater than this critical t? If it's less than critical t, we're saying it's in this direction, we would fail to reject. If it's greater than critical t, then we're saying it's in this direction, and we would then reject the null hypothesis. So that's the basics of the steps. And so in the next videos, what we'll do is we'll go over the equations, the different types of t-tests and their equations, and then we'll work out an example so that this will help clarify things. Hope you enjoyed this video.